I'm recording it. Okay, so like I said, y'all, we got a couple of options. I can continue lecturing and I can go over it. I can finish up. There's only a couple of problems left here in 3.2. I think it was just these two right here. And then I can go through 3.3. And I do want to make sure that I have some time for homework questions. So I'll tell you what, we should have time for me to go through the last part of 3.2. Or do you guys want me to start with 3.3? I just want to make sure that, like, if you guys have questions that I have time to answer them. So are there any questions that you guys have already, that you know already? 3.2. So Laura, do you want me to finish up 3.2, or do you want me to answer some homework questions from 3.2? Whatever is easier for you. You can either turn on your mic or you can put it in the chat, whatever is easier. You got stuck on homework, or is that where you got stuck? On the homework? Okay, do you remember which questions you were stuck on? And we can definitely do that today, y'all. And while Laura's looking for her problems, does anybody else have any homework questions that you all want me to address? Let's see. Antonio, I know you're here, and Matthew, I know you're here as well. Do either of y'all have any homework questions that you want me to go over while Laura's looking for her problems? Let's see. Oh, that's okay. Don't worry, Laura. You can keep typing. You're good. Let's see, I heard something in the chat. Come back here. Number 7, definitely. So I'll tell you what, let's do number 7, y'all. And let me go through here. Let me find my number 7. Okay. So I'm gonna copy and paste the problem, y'all, in my notes for us here. So let me see. Let me copy this. Let's bring this down. Bring this down. And oh, it's from 3.1. Okay, so let me go back to 3.1. So let me go like this. Okay, 3.1, numero 7. And let's see. Okay, yes. So let me see if I can do this the way it needs to be done. Okay. And I'm trying to figure out if I can. I'm trying to do a little copy and paste here with y'all. Actually, you know what? I'll do it this way. So let me stop that there. And let me do it like this. Okay, so let's come back here. Let me stop sharing this part with you guys real quick. And I'm going to pull this up right here. Okay, so I think you guys can see this now. Okay, so what we're trying to do, it says drag each graph on the right in column 2 to match the corresponding restrictions in column 1. Okay, so I'm going to look here, y'all, at 45, and I think you can see my mouse kind of moving around here. So first thing I noticed about 45, this first part right here, y'all, I don't think it's not letting me, I was trying to kind of like highlight it or whatever. But this first part right here says A is less than 0. So when A is less than 0, that means the graph is going to open down. So I know it's either going to be this one, or this one right here. Okay, so the graph's going to open down because A is less than 0. So I'm going to share something with you guys real quick. So let me stop sharing this part again. I'm going to come back to my notes because I want you all to see something in my notes. And I'm coming back up here. This is what we were doing last week on, yes, on 3.1. So let me scroll back up. And I know I'm kind of scrolling a little fast, but we will get there in a second. Okay, so last week when we were in class, y'all, and we were talking about the graphs of these things here, we said that if A was negative, the graph was going to open down, and if A was greater than 0 or positive, then the graph was going to open up. So that's something that I'm going to be looking at, okay? So when A is less than 0, graph opens down. When A is bigger than 0, the graph opens up. Then the other thing that we talked about was, and I'm just going to kind of scroll through here till I find it. Here we go. This part right here, y'all. So let me get my pen. And what I want to let you know what I'm looking at is this part right here. And I'm actually going to zoom out just a little bit so that you can see everything. And I'm really looking at this part. Okay, so remember what we said right now. If A is positive or if A is greater than 0, the graph's going to open up. And if A is less than 0, then the graph's going to open down. Then the other thing that we talked about was trying to get my eraser. I'm trying to erase those little circles like this part right here. Okay, so the other part we talked about was the discriminant. The discriminant is the number that's on the inside of the square root. Okay, so this is what I'm going to use in doing problem number 7 from 3.1. So, in dealing with the discriminant, we're looking at if the discriminant is greater than 0, then we have 2 x-intercepts. If the discriminant is equal to 0, we have 1 x-intercept. And if the discriminant is negative, then we don't have any x-intercepts, okay? So basically right here, everything that I have on this page, y'all, this is what I'm going to use to answer those questions from number 7 on 3.1, okay? So I don't know if you can or whatever, but you might want to, if you have your phone with you guys, you might want to just take a quick picture of this just so that we can use it as a reference so that I don't have to keep going back and forth so much. But I'll actually show you something. I'll do it in a way to where it should make it a little bit easy breezy cover girl. So look, let me stop sharing it like this, and I'm going to share the entire screen. But what I'm going to do, yeah, I know it looks real weird. Okay, can you guys still see my screen? Can you still see the notes? Are we good with the notes? Can everybody see that? Yeah, let me see. Like this, we come back. I know that probably looks weird. Okay, great, awesome. Thank you, Claudia. Thank you, Laura. Okay, so look, here's my problem right here, right? These are things I'm going to look at. And then what I want to do is I'm going to pull up this problem, and I want to make, yeah, you guys can see this too. Okay, so first thing I notice, A is negative, so we said the graph is opening down. The second part tells me that this b squared minus 4ac equals 0. So when I come back and I look at my notes, when it's equal to 0 right here, the second one, I'm going to have 1 x-intercept. So I know my graph's going to open down, and I'm going to hit the x-axis just once. So when I come back here, my graph's going to open down. So it's either this one, or this one. And it should be this one here because it only hits the x-axis once. If I zoom in, and it's not really letting me zoom in too much, but you can kind of see as I'm zooming in, maybe this does it a little bit better. Yeah, you can see that it only hits my x-axis one time. So what I need to do is I need to take this guy here and put it right there. Okay. So I'll tell you what, let's do the ones that are opening down. So remember, the ones that are opening down is when A is less than 0. So if I look at 47, A is less than 0 right here. B squared minus 4AC also less than 0. So I'm going to come back because I heard something in the chat. And, okay, good, Lotto. I'm glad it's working. Okay, so I'm going to come back to my problem, and I'm looking at 47. A is less than 0, so is b squared minus 4ac. So when I pull up my notes, if b squared minus 4ac is less than 0, that tells me I don't have any x-intercepts, right? So what I'm going to do is I'm going to say, okay, look, for 47, the graph's going to open down, and it never hits the x-axis. So if I click on this one here, notice the graph opens down, and it never hits the x-axis. So that's telling me that this one right here is going to be number 47. And there has to be one more that's opening down, 48. Okay, so 48 also opening down, y'all. The discriminant is positive. So if the discriminant is positive right here, notice we're going to have 2 x-intercepts. So when I come back to my problem, this one right here, if I open it just so I can look a little bit better, it's opening down, and it does hit the x-axis twice. And so this guy right here is going to get moved to 48. Okay. Now, so now we know that we have 3 more problems, and there's 3 more graphs. Okay. So all of these, if you notice, A is positive, A is positive, A is positive, tells me my graphs are opening up, right? Okay. So let's look at 46. Not only is the graph opening up, but the discriminant is less than 0, right? So when I come back to my notes and I say, look, when the discriminant, it's number 3, is less than 0, we don't have any x-intercepts, right? So when I come back to my problem, I say, look, it's going to go up, and it shouldn't hit the x-axis like the way this one does. It's opening upward, but it never hits this line right here. So that's telling me that this one here needs to go to 46, right? And then let's take a look. Let's look at 49. Again, the graph's opening up. The discriminant is positive. So when I come back to my notes, if the discriminant is positive, that tells me I'm going to hit my x-intercept, or I'm going to have 2 x-intercepts. So my graph's going to hit the x-axis twice. So I'm going to come back again to my problem, and I say, look, I need to find one that opens up and hits the x-axis twice, like the way this one does. Hits it once right here and once right there. And then so what I'm going to do is I'm going to take this fella, and I'm going to put it right there. And then by process of elimination, y'all, this one here has to go to the end. And let me hide that real quick. And then I'm going to check my answer, and we got it. So let's see. Laura, did that make sense on how I was able to figure out number 7 from 3-1? I know that looks real messy, so I'm going to stop sharing that part real quick. Boom. But did that work for number 7? Yeah, we're good. Okay, awesome, great. Okay, so y'all remember what we're doing. So Antonio, I see you're here. Matthew, Laura, Claudia. What I'm really doing is I wanted to ask you guys if y'all had any homework questions, and if you do have any homework questions, any of y'all that are here, let me know, and we can definitely go over some of those. So y'all, one of the things I said I can do, and I really just want to make the best use of our time tonight. You know, I know it's different because we're not actually there with each other. So, you know, Laura said she wanted me to go over number 7, so we did. And Laura, if you still have questions, I'm still happy to go over any questions that you might have. So y'all, the other thing I said we could do was when we were in class last week, we did almost all of 3.2, but this is where I had stopped. So I don't know how many of y'all have had a chance to, you know, finish your homework for 3.2 or do anything from 3.3. But one of the things that I can do as well tonight is I can finish lecturing on 3.2. There was just 2 more problems that I needed to do. And I can also go over the material for 3.3. So what do you guys think? I'll put it this way. We'll go like this. I'll give you guys 2 options. Choice A, answer more homework questions. And choice B, finish covering 3.2 and go over 3.3. And guys, it's not an either or. We can do both. B, Antonio says B.
Sir, can we go over number 10? I'm sorry.
Yes. Yeah, definitely. From which section?
3.1.
3.1, number 10. We're going to do it right now.
Thank you.
So look, of course, you're welcome. So guys, let me pull up number 10. Here we go. And so guys, I'm going to share my screen with you, and then y'all, I'll definitely continue with 3.2 and 3.3. I'll definitely do that as well. Like I said, it's not just one or the other. We can definitely do both of them, okay? So let me go like this. Okay, and let me pull up the homework question. Okay, so you guys can see the problem here, and it says, find a quadratic function having the graph shown, and then, so here's my picture. All I'm going to do, y'all, I'm going to make this picture a little bit bigger, and where is it? I got a little cropping tool right here. I'm going to copy and paste this in my notes so that we can do the problem, okay? So let's go like this, and I'll do it over here so we can take a look-see. Boom, there we go. And let me make sure you guys, yep, you guys can see what I'm doing. All right, so let's take a look here, y'all. When I'm going to do a problem like this, the first thing I want to think about is how would I write my equation in what we call the vertex form, okay? So just to give you an idea, this right here, y'all, is called the vertex form, okay? And so remember, my vertex is always going to be my point H and K, right? And so if you look right here, y'all, I'm going to zoom in just a little bit. Here's my vertex. So this is my H, and that's my K. So what we're going to do, we're going to write f of x equals a, x minus h. H is the number 5 squared. And then k, look at the number k. K is the number -5. So I'm going to put a -5 right there. Okay. So now that I got to that step right there, remember when I'm writing this thing out, y'all, I can write it using f of x. If it's easier for y'all, we can always write it using y, because y and f of x mean the same thing. So like I'm looking at who's here in class. One of the persons now who's here is Antonio. So Antonio, I don't know if you go by Antonio or if at home they call you Tony, but think about it this way. Think of this as this is Antonio and that's Tony. It's the same thing, okay? So it's just another way of writing it. All right, so since we have that, y'all, the other thing we know here, and let's see, I heard something in the chat, so let's see what this is. Boom. He says he got it. Awesome, good, perfect. So this is my x and this is my y, okay? So what I'm going to do now, y'all, where the y used to be, I'm going to put a 0 equals a. Where the x used to be, I'm also going to put a 0 minus 5 squared minus 5. And what we need to do here from this step, y'all, we need to solve for the letter a. So I'm going to put 0 equals a. So 0 minus 5 is a -5 squared minus 5. Okay. And then -5, when I square it, gives me a 25a minus 5. Okay. And we're trying to solve for the letter a. So what I need to do is I need to move this number that way. So that's going to give me a +5 because I'm crossing the equal sign, equals a 25a. So when we divide both sides by 25, we come up with a. I can reduce this to 1/5. Okay. So now that I have that, now that we've reduced that to 1/5, what we're going to do, y'all, we're going to come back to this part right here, and we're going to replace this with that 1/5. So we're going to write it like this. It's going to look like f of x equals a, which is 1/5, x minus 5 all squared minus 5. And here's my answer, right? We wrote it out. And then just to show you that we're going to get the same thing. Okay, so if you notice right here, here is the problem, right? So the first thing I'm going to do, I'm going to put a little fraction, 1/5, and then parentheses, x minus 5, close them off. I need to square that. And then a -5 at the end, right? So if you notice what I wrote right here, y'all, that's the same thing that I have, let's see, right there, right? So I've just wrote it in there. And then now I'm going to go, let me check my answer, and we got it. So what do you think? Did that one make sense? Were we good with that problem there?
Yes, it did. Thank you.
Yeah. Okay,
Yes.
you're welcome. Guys, so awesome, Lada. Thank you. Appreciate it. So any other questions before I continue with 3-2 and 3-3? Again, guys, we have plenty of time. So 6:20, we got a lot of time. We're going to have a lot of time to still go over 3-2 and 3-3. So if y'all definitely, if you still have any homework questions, I'm still happy to answer any of them.
Sir,
Yes, ma'am.
On the same section 3.1, number 11, because
Yeah.
Can you go over that one too, please?
Yeah, of course. We will. So guys, remember, we got plenty of time. So if you got questions, don't feel shy to ask me or anything, because we got a lot of time to go over them, okay? And we'll still have enough time to do the next part as well. Okay, so look, y'all, this problem right here, very similar to the one we just did. The first thing I'm going to do, I'm going to open this up just so I can get a better idea of what my picture looks like. And just like we did before, y'all, I'm going to copy and paste this because I want to get a good idea of what's happening here, okay? So let me copy this here. Let me pull this over here and paste it. Here we go. Okay, so we're going to do this problem, y'all, just like we did the one before. So again, I know my numbers might be different from yours, but the idea is still going to be the same, right? So notice I'm going to go like this. Y equals a x minus h squared plus k, right? Okay, so remember, y'all, this is a vertex form. Here's my h and here's my k. So I'm going to zoom in just so we can see that a little bit better. Look at the h. The h is a -4 and the k is a +8, right? So when I write this out, it's going to look like this. A x minus, we said h was a -4, plus k, we said k was a +8, okay? Now, the other thing that we know, y'all, is this point down here. Remember, this is my x, and this is my y, okay? So before I even start doing that the first thing I want y'all to notice, if I have a minus -4, let's write it as a +4, okay? And then where the y used to be, I'm going to put the number -8 equals a. Where my x used to be, I'm going to put the number 0 plus 4 squared plus 8, okay? So look, -8 equals a. 0 plus 4 is still 4 squared plus 8, okay? And let's see, -8 equals 4 squared, I know is 16, so that's 16a plus 8. Now, since I'm trying to solve for the letter a, I'm going to go look, -8 and -8. So this +8 and that -8 are going to cancel each other out. But over here, a -8 and another -8 is a -16. And then so now I'm going to divide everything by -6 or by 16. And -16 divided by +16 is a -1. Okay. Remember what we said, y'all? That if my number a was negative, then the graph was going to open down. And if we notice here, our graph is opening down, right? So just like we did before, what I'm going to do is I'm going to come back over here and I'm going to rewrite the problem. But instead of me using the letter A, I'm going to put a -1. So I'm just going to write it like this with a minus. I don't necessarily need to put the 1. And then x plus 4 squared and then plus 8. Right? And so here's my problem. And then remember, y'all, on my lab, the only thing I'm going to enter in is this part right here. So let me pull up my problem. Here it is. And we said we're going to put a negative and then parentheses, x plus 4 squared. I got to square that. So, where's my square? Right here. Oh, why did it go away? There we go. Squared. And then we had a plus 8 at the end of that. And then we can go check. And we got it, right? So let's see. Claudia, did that make sense for that particular problem? Am I good on how we did 11?
Yes. The only thing
Yeah.
that I'm getting confused is when I put the H and the K, what numbers do I plug in? I think that's what's just throwing me off. You know how you
Okay,
did the
so
and the X and the Y?
yes. So think about it this way. This point here, the point here at the top is
Mm-hmm.
always going to be my H and my K,
Okay, got it.
right? And so if it has a -4, that's why originally here, let me get my eraser. That's why originally here I had a minus -4, right?
Uh-huh.
But then we said, well, because it's minus and minus, it becomes
Okay.
plus, right? But
Yes.
yeah, this here is always going to be my HK. Same thing with the one that we did here.
Yes.
So the
Four.
vertex, y'all, very good. So guys, I want to point something out here. Remember, and I'm just going to kind of do this on the side so that when you're doing these kind of problems, when your graph opens up, the vertex, y'all, is going to be the lowest point in the graph. And when your graph opens down, then the vertex is going to be the highest point of the graph. But that's always going to be my vertex. This will always be my H and K. Same thing with that one right there. And then whatever other point they give me will
Mm-hmm.
be the point that we use for X and Y.
Okay. Yeah, got it.
Got it? Good,
Yeah.
good. Excellent. Hey, anybody have any other questions y'all want to ask me about 3.1, 3.2? Like I said, y'all, we still got plenty of time. We got an hour and 20 minutes. It's going to take me maybe 45 minutes, maybe an hour to do the rest. But I'll tell you what, let me go ahead and go through the rest of 3.2. Let me go through 3.3. And then if there's any questions you want to ask me afterwards, we'll definitely do that, okay? So, and then y'all, even if, if there's certain questions we don't get to, remember, you can always message me on Prano, send me a picture of the problem. I'm happy to make a video. I'll send it out to the entire class, okay? So I'll tell you what, let's go ahead and finish up 3.2. Okay, so 3.2, the last part of it here, y'all, talks about these things called potential zeros of polynomial functions. And it says a zero of a polynomial function f of x is a number k such that f of k is equal to 0. And it says real number zeros are the x values of the x-intercepts of the graph of the function. Okay, and it says the remainder theorem gives a quick way to decide whether a number k is a zero of the polynomial function. And it says we're going to use synthetic division to find f of k. And if the remainder is 0, then that number k is what we call a zero of the function. And if it's not 0, then it's not a zero of the function. Okay, so let me explain the easy breezy cover go way of doing this thing. And so the easy breezy cover go way, hopefully, y'all, of doing this thing here is we're going to use synthetic division. So the first thing I'm going to do here is I'm going to draw my half box, right? And I'm going to use the numbers that I have in my polynomial using the coefficients or the numbers in front of the x's, right, with their signs. So the first number I have is 2, -6, -9, and 4, okay? Now, last Tuesday when we were in class and we were doing synthetic division, we were dividing by stuff like x minus 5, or we were dividing by things like x plus 3. And the first thing I told you guys is when we're doing something like this, we got to take the sign and we got to change it, okay? But when it's in this form, when it's in the form k equals, the sign has already been changed for us. So we don't need to change the sign. So the number that I'm going to write out here, y'all, is just going to be the number 1. The sign, again, has already been changed for me. So what we're going to do, we're going to do synthetic division. We're going to bring down the first number, which is 2. And then remember, we multiply. 1 times 2 is 2. We add straight down. That's going to give me a -4. We multiply again. 1 times -4 is a -4. We add these numbers together. That is a -13. And then we multiply one more time. 1 times a -13 is still a -13. And when we add these numbers together, I'm going to get a -9. Okay, so remember, the last number, y'all, here always tells me the remainder. The way we would know if k equals 1 is a 0, because that's the number that they gave me right here, the way I would know if it was a 0 is if the remainder were equal to 0. Since the remainder is equal to -9, we would say this is not, well, I would write it like this. I would probably write k equals, I was going to try to write it in English and math at the same time. K equals 1 is not a 0 because f of this number, f of 1, is equal to -9. Okay, so now how do I know, again, if it's going to be a 0? The way I know it's going to be a 0, y'all, is if the remainder happens to be 0. So look, let's try to see if the second problem, maybe this one will work. Okay, so I'm going to take this problem here and I'm going to zoom in. I'm going to do my synthetic division. So I'm going to draw my half box. And remember, I'm going to write the numbers here with their signs. So 1, 2, -1, and a +6. Remember, y'all, when it's in the form k equals, the sign has already been changed for me. I don't need to worry about changing the sign. So I'm going to put that number -3 out there. Step number 1 says, let's bring the first number down and multiply. So -3 times 1 is a -3. We're going to add these numbers together. That's a -1. We're going to multiply again. -3 times -1 is a +3. We're going to add those numbers together. That's going to leave me with a 2. And I'm going to multiply again. -3 times 2 is a -6. And when we add together, we get 0. Remember, this number here is our remainder. Okay? Since we got 0 for our remainder, what we would say is k equals -3 is a 0 of the function f. That's all it means for it to be a 0. It means that that value, when you plug it into the function or when you use synthetic division, it will give me a 0 for my remainder. Okay? So I tell you one thing I'm going to do. Before I go on to, let me get rid of this real quick. Before I go on to, what is it? Before I go on to 3.3, I'm going to pull something up real quick. So I'm just looking at my lab here, y'all, and I'm going to pull up 3.2, and because these were the problems we were doing. So let me pull up number 11, and I want to see, here we go. So number 11, y'all, this problem here is almost identical to the one we just did. So look, I'm going to copy and paste this problem here. And again, this is my number 11 out of 3.2. And so what I'm going to do, I'm going to copy this, and I'm going to put it over here in my notes, and we'll work this problem out together. So again, you can see that this problem here, just like the ones that we did right now. So the question here says, use synthetic division to decide whether the given number k is a 0 of the polynomial function. If it's not, give the value of f of k. All right. So I'm going to do this problem just like we did before. I'm going to write my half box. Remember, I'm going to use the numbers that I have here. So 5 with their signs, -18, -9, 46. Notice it's in the form k equals. So the sign, again, has already been changed for me. Here's my 3. And we're going to use synthetic division. Remember, first step, bring this number down. Okay, we're going to multiply. 3 times 5, 15. We're going to add these numbers together. -18 plus 15 is a -3. We're going to multiply. 3 times -3 is a -9. We're going to add together. That is a -18. And 3 times -18 is, in fact, -46. So we get 0 here. Remember, this is my remainder. So the question is it a 0? We would say, yeah, it's a 0 of the polynomial function because we got 0 as our remainder, right? And so if you notice, y'all, I'm going to come back. I'm going to pull the problem up. I think you can see this in, let me see. Let me come back over here. Oops, that looks real weird. Okay. And let me see if I can do it like this. And yes, you guys can see that now. So we're going to click on B. Yes, this is a 0. Check it. Oh, it says it isn't. Okay, why not? What did I do wrong? Did I do something wrong? Maybe I did. Let me come back. Oops, I made a mistake maybe. Let's see. 3 times 5, 15. Negative 3, negative 9, negative 18. Why? Let me get my calculator. Maybe I made a mistake. Oops. Let's clear. I'll turn it on first. Clear all that. Let's see. 3 times negative 18. Negative 54. That's why. That's where I made my mistake. Oops. Okay, so oops. That was my bad, y'all. That was my mistake. Okay. This here is a negative 54. Okay. So when I add these together, that's a negative 12. Okay. Oops. Okay. So here's my remainder. Okay. So I'm going to, I was just kidding. Okay. So it's not a 0 because f of 3 equals, right here, I'm going to put negative 12. Okay. So now let me come back. Let me check this again. So it's just kidding, not that one. And we're going to put this one here. And we're going to go negative 12. And we're going to check our answer. Oh, it's still not working out. ¿Por qué no? Let me see, y'all. I'm making some mistakes this afternoon. Why? Oh, it's not negative 12. Isn't it negative 8? I think it's negative 8. And I heard somebody put something in the chat. Negative 8. Thank you, Antonio. Yeah, my bad, guys. My bad. Negative 8. Oops. Okay, I got to put oops again. Right? So let's see. Yeah, negative 8. Thank you, Claudia. Thank you, Antonio. So, guys, let me come back here. Oops. So let's go like this. Negative 8. Final check. All right, there we go. We got it now. Okay, so there we go. Sorry about that, y'all. But yes, you can see how I'm doing the problems. It's the same exact way, right? That's all I'm really trying to do here is figure out if this thing is a 0, the function, or if it isn't. So let's see. Let's keep going here, you all. So let me come back over here. So we went through 3.2. Let's go through 3.3. And let's see if we can figure this stuff out as well. So 3.3 is zeros of polynomial functions. And so it says determine, with a factor theorem, I'm sorry, says for any polynomial function f of x, x minus k is a factor if and only if f of k is equal to 0. Okay, so we're going to do the same thing we've been doing, y'all. I'm going to draw my half box. Okay, I'm going to use synthetic division. I'm going to fill the numbers in. I want you to notice something. We have an x to the 4th. Since we don't have an x to the 3rd, that's the number in front of the x to the 3rd. I got to put that 0 in. Here's my x squared. Here is my x. Here's my constant number. We're trying to determine whether x minus 1 is a factor. So the difference in this problem, y'all, and what we did right here at the end, see how this was in the form k equals? And let's see. This is not in that form. This is a one where I need to change that sign. So instead of me writing a negative 1, I'm going to change the sign. This one needs to be a positive 1. Okay. So now, first step, let's bring down my 2. And let me multiply. 1 times 2 is 2. We'll add together. That's still 2. 1 times 2 is still 2. 2 and 3 is 5. We'll multiply again. 1 times 5 is 5. We'll add those together. That is 0. 1 times 0 is 0. We'll add these together. That's 7. Okay. So remember what we said? This number here is my remainder. Okay. What this is telling me is this thing here, or this part, would be a factor if the remainder would happen to be 0. But the remainder is not 0. The remainder is 7. So is x minus 1 a factor? I would say no. X minus 1 is not a factor since f of 1 is equal to 7. okay? And in order for it to be a factorial, the remainder needs to be 0, okay? So look, let's try the same thing for the next problem. So first thing I'm going to do, I'm going to zoom back in because I did zoom out quite a bit. And we're going to use synthetic division again. So 3 is the number in front of the x to the 5th. There's a number in front of the x to the 4th, the number in front of the x to the 3rd, the number in front of the x squared, the number in front of my x, and then my constant term. And it's, remember, we're dividing by x minus 1. So I need to change this sign to a positive 1, right? And I'm going to bring down my 3, first step, and then we're going to multiply. So 1 times 3 is 3. Negative 2 and 3 is a positive 1. 1 times 1 is still 1. Add those together, that's 2. 1 times 2 is still 2. Add those together, that's a minus 6. 1 times negative 6 is a negative 6. Add these together, that's a minus 1. And then 1 times negative 1 is a negative 1. Add those together, and it's 0, which is what we want. So then we would say, yes, x minus 1 is a factor of this polynomial right here. Okay? So the easy way to sort of think about this, right? And I know this is, synthetic division, and I think synthetic division, most of us feel pretty good with synthetic division. So the way to think about this is, I know last Tuesday when we were in class, do you remember when we said, look, let's take 9 and let's divide it by 2? Because I think this was the example we used in class, and we said, look, 2 goes to 9 4 times, that's 8. We subtract, we get a remainder of 1. So we would say that 2 is not a factor of 9 because we have a remainder, right? So when we did this problem over here, notice we had a remainder, right? So that's why it's not a factor. But if I were to ask you, is 2 a factor of, say, 12? And you would say, look, it goes in 6 times with no remainder. So we would say, yeah, 2 is a factor of 12. Why? Because it goes in nice and neat. There's no remainder, right? And that's kind of the idea of what's happening with these problems. So if you don't have a remainder, meaning your remainder is 0, then we're good. We have a factor. But if you do have a remainder, then we say it's not a factor. Okay. So let me keep moving along here. Okay, and let's take a look at this next one. And it says factor f of x equals 6x to the 3rd plus 19x squared plus 2x minus 3 or minus 3 into linear factors, given that negative 3 is a 0. Okay, so the first thing I want to mention to us, they told me negative 3 is a 0. That means that x is equal to negative 3. Okay, so I'm going to do synthetic division again. I'm going to put my 6, my 19, my 2, and my minus 3 right here. So remember, y'all, when it's in the form k equals or x equals, the sign has already been changed for me. I don't need to worry about changing my sign. We're going to do synthetic division. So we're going to bring down my 6, and we're going to multiply. Negative 3 times 6 is a negative 18. We're going to add straight down. That's going to leave us with a 1. Negative 3 times 1 is a negative 3. We're going to add those together. That's going to leave us with a negative 1. And we're going to multiply one more time. Negative 3 times negative 1 is a positive 3. And notice what we get. We get a remainder of 0, right? And we should, because they told us from the beginning that negative 3 was a 0. Now, what we're trying to do is we're trying to factor this thing into linear factors. Okay, so let me explain what that means by linear factors. So remember, we used to have an x to the 3rd polynomial. Since we divided it by an x polynomial, this is really the number in front of the x squared. That's really the number in front of the x, and that's my constant term. So what we really have now is we have 6x squared plus 1x minus 1. And what I want to do is I want to see if we can factor this thing. So remember, y'all, when I'm going to factor something like this, my first step is take the first number and the last number and multiply them together. So 6 times negative 1 is a negative 6. And then I'm going to think of all the numbers that I know multiply to negative 6. Well, 1 and 6, 2 and 3. I need to find the pair of numbers that are going to multiply to negative 6, but when we add them together, we get a positive 1. So number one, because this is a negative 6, one of these numbers here, these pairs, and one number in the pair is going to have to be negative, one will have to be positive. So look, if we make that into a negative 2 and a positive 3, when we multiply them together, there's my negative 6. But if we add them together, negative 2 plus 3 gives me my plus 1. So now we're going to rewrite this. 6x squared minus 2x plus 3x minus 1. And what I'm going to do is I'm going to put a box around these first two. I'm going to say, okay, look, what can I take out there? Well, because it's 6 and 2, we can take a 2 out, and they both have an x, and we're left with a 3x and a minus 1. And then I'm going to put a circle around these two. And if I try to factor anything out of here, I really can't take much out. But we can always factor out the number 1. And when we factor out the number 1, nothing really changes. Okay? So now I want you to notice something. This piece here and this piece here match up. So I'm going to have a 3x minus 1. And then this piece and this piece are going to go right next to it, 2x plus 1. Okay? Now we're almost done. I'm going to come back to my original problem. Remember how we said that x equals negative 3 was a 0? What I want to do is I want to pull that negative 3 back over there. That means the factor that I really have is x plus 3. Okay? So I'm going to write here next to it, I'm going to write an x plus 3, and this is going to be my f of x. And all we've really done here, y'all, is we took this original problem and we factored it out. Okay? And when they say, and we come back over here just so we can see a couple of things, when they say linear factors, all they mean by linear factors is that the x's are just x's. There's no x squareds or x thirds or anything like that. No, they're just x's. That's what they mean by linear factors. That's why when we got to this step right here, I had to keep factoring it out so that we could break everything down completely. Okay? So look, before I go on, let me do this. Let me stop sharing that part right there. And let me do this real quick. And let me ask you guys a question. Are we doing okay so far? Are we all together on the same page? Am I losing you, or are we good? What do y'all think? Anybody? Yes, yeah, definitely. We got a couple more to do like this, so we're definitely gonna do some more, okay? So I'll tell you what, let's keep working here then, and I want to make sure that we're good. Guys, at any point in time, if I'm doing something and it doesn't make sense, either put something in the chat box or turn on your mic and say, sir, what did you do? I lost you there, okay? Tell me, as soon as you get lost, y'all, tell me so that we can go over it before we keep going, okay? So look, we're going to do the same thing that we did here before. And it says factor the given polynomial into linear factors. Okay, so first thing I'm going to do here is I'm going to draw my box. Okay, so remember, this is a 1, a 1, a 2, a negative 7, a minus 20, and a minus 12. And look what they're telling me, k equals negative 2. I'm going to tell you what this part means in 1 second, okay? But the number that's really important here, y'all, is that negative 2 happens to be one of the zeros. One thing, again, I want to emphasize, see how it's in the form k equals? So again, I don't need to worry about changing my sign. So remember, first step, drop down the 1, and we multiply. Negative 2 times 1 is a negative 2. Okay, so that's going to give me a 0. Negative 2 times 0 is 0. That's going to give me a minus 7. Negative 2 times negative 7 is a positive 14. Okay, and then let's see, negative 20 and 14 should be a minus 6. And negative 2 and negative 6 is a positive 12. So again, here's my remainder. It happens to be 0, right? Okay, so remember what we used to have, y'all? We used to have an x to the 4th. So this is really my x to the 3rd. That's really my x squared. That's really my x, and that's my constant number, right? Okay, now I told y'all what does this multiplicity 2 mean? It means that we can do this twice, that we can continue using synthetic division, and we can use negative 2 another time because the multiplicity is 2. The multiplicity just means it's going to work twice, okay? So look, we're going to go through it again. First thing we're going to do, we're going to drop down the 1, okay? And we're going to multiply. Negative 2 times 1, negative 2. When we add those together, still a negative 2. Negative 2 times negative 2 is a positive 4. We're going to add those together. That's a minus 3. And negative 2 times negative 3 is a positive 6. When we add those together, there's my 0, there's my remainder, okay? All right, so again, I want to emphasize something, y'all. Remember we had an x to the 4th polynomial? The first time we did this, we reduced this to an x to the 3rd. But we did it a second time. So now that's really the number in front of my x squared, and that's really my x term. So what I need to do now is I need to say, can I factor x squared minus 2x minus 3? And yes, we can. Now this one should be easier for us to factor because the number in front of the x squared is 1. So remember, when the number in front of the x squared is a 1, I'm just going to multiply the first and the last. So 1 times negative 3 is negative 3. And I'm going to think of all the numbers that multiply to negative 3, but I want to find the pair that add up to a minus 2. So we could use a positive 1 and a negative 3. They multiply to negative 3. They add up to a negative 2. And then we can write it like this. X plus 1, because that's the number I got right there. X minus 3, because that's the number I have right there. Okay, we're almost done. I'm going to write it like this. F of x equals. Okay, so I'm going to come back. And I'm going to look at what we had to begin with. See how we had it as k equals 2? So I'm going to write it as x equals 2. It's the same thing as writing it as k. It's just using the letter x. Remember, when I bring this 2 over so I can write it as a factor, wouldn't that be x plus 2? And because we did that here, and we did that here as well, that means I have another factor of x plus 2. So because we had our multiplicity of 2, we had this factor twice. So what that means is right here, I'm going to put 2 more x plus 2's. And if you wanted to, it's up to you, but if you wanted to, you could write it like that. Either way, we're going to end up with the same thing, okay? Which way is better? They're both the same, okay? One isn't any better than the other. What do y'all think? Was that one any better than the first one, or do you feel like it makes more sense now, or are we doing okay here, y'all? Anybody? We're good? More sense, Laura? Okay, awesome. Anybody else? If you're lost, guys, please let me know. I want to make sure that you guys feel okay about this. So if you're lost, please tell me. Don't be embarrassed. Don't be shy. My goal is to have you leave here tonight not feeling lost or anything like that. Anybody? Are we good? Are we good? Okay, so then let me keep going here, y'all. We still got a little bit more of 3.3. Okay, so it says for each polynomial function, 1, 0 is given. Let me see, I heard something in the chat. Let me come back. Let me double check. Yes, Antonio, you can definitely come back to, oh, yes, I am recording it. Yes, we're recording. Oh, man, I got nervous there. I thought we weren't recording. But definitely, we can definitely use it as a reference. And then, Antonio, remember, I do have the YouTube playlist. I'm doing the same thing in the playlist that I'm doing here. The only difference is that we're all here together, right? But definitely, yes. Yeah. And I'm glad we are recording it. Okay, so let's take a look here. It says, for each polynomial function, 1 0 is given. Find all the other zeros. Okay, so let's take a look here. We want to find the zeros of the polynomial function. So the first thing it tells me, 1 0 is given. This is the zero that we have. So this is already in the form, y'all. X equals that number. Okay, so this is one of the zeros. I want to point something out. Since this problem has an x to the third, that means that we're going to have 3 answers. Okay, so we already have one of them. We need to find 2 more. Okay, so let me show you how we're going to do this. First thing I'm going to do, I'm going to draw my half box, and I'm going to put my 1, my -1, my -4, and a -6. Okay, so remember, since this is the zero that they already gave me, and it's in that form x equals, then the sign has already been changed for me. So I'm going to put the 3 right here, and we're going to do synthetic division. So we drop down the 1. 3 times 1 is 3. We add these together. That's going to leave me with a 2. 3 times 2 is 6. We add these 2 together. That's going to leave me with a 2 again. And 3 times 2 is 6. And we add these together, and there's our 0 for remainder, right? So again, remember what it told me. It said 1 0 is given, and it gave me that number. And they were right. It was a 0, right? Because we got a remainder of 0. So remember what we said, y'all. This is my x squared, and that's my x. So what I need to do is I need to solve this equation, because I'm trying to find the zeros. What this means is I'm going to set this part right here, I'm going to set it equal to 0 so that I can find those x numbers. Okay, remember what we said, we need 2 more. Here's one of them, right? Okay, so now if we were going to do factoring, the first thing I would say is, look, that's a 1. So 1 times 2 is 2. And now I'm looking for 2 numbers that multiply to 2 but add up to 2. Well, the only numbers that I know multiply to 2 are 1 and 2, but if I add them together, I get 3, and that's not going to work. That's okay. All that tells me is I cannot do factoring, and I need to do the quadratic formula. Really? I thought we were done with that. Not quite yet. Okay, so here's, remember, my A, B, and C, and we're going to use the quadratic formula. So remember, the quadratic formula, see, I'm going to sing it to you. X is equal to -b plus or minus the square root of b squared minus 4ac, all divided by 2a. See? I'm going to go on American Idol. All right, so here you go, y'all. So remember, here's my formula. All I'm going to do now, plug and chug, right? So negative, what is b? B is the number 2. Plus or minus the number b squared minus 4 times a times c. All of this is being divided by 2 times a. Okay? So we're going to go x equals, let's see, -2 plus or minus, let's see, 2 squared is 4, minus 4 times 2 is 8. Okay, all over 2. We're almost done. X equals -2 plus or minus 4 minus 8 is actually a -4 all over 2. Okay, I'm going to write it over here because I am running out of room. X equals -2 plus or minus. Okay, let's see if we remember the square root of -4. So remember, because there's a negative on the inside, the I is going to come out, right? And then the square root of 4 is just 2 all over 2. And then remember, all I'm going to do here, y'all, is I'm going to divide these numbers all out, right? So we can divide them all by 2. So that's going to leave me with a -1 plus or minus I. Now remember what I told y'all, that we were going to end up with 3 answers, right? So look what we got, -1 plus or minus I. Remember what that means? That one of them is -1, oops. One of the answers is -1 plus I, and the other answer is -1 minus I. And those are my three answers right there, okay? Let me see if I can zoom out just a little bit so we can kind of see everything. Boom, there we go. Okay, so this is what it means for me to find the zeros when I already know one of them, okay? So ideally, y'all, I always like to try to get my problem to end up with an x squared, because even if I can't factor it, then I can always go back and say, you know what, let me do the quadratic formula. And even though the quadratic formula takes a little bit of time for me to do, we've done the quadratic formula a bunch of times, right? This is when we have our calculator. The calculator is going to help me figure out how to do some of these steps. You know, if my numbers are really big, but hopefully I don't have really big numbers. Let me see, I heard something in the chat. So let me go here. And yes, Laura, we definitely could have used the quadratic formula on the problem before. Very good point. So guys, let me come back. I'm glad Laura brought that up. So when we did, where was it? This one here, yes. When we did this problem right here, we could have used the quadratic formula. My thing though, and again, y'all, it's really up to you all on what you find easier. So I'm going to give you like a little side note, and I'm going to point this out right here. So what is it? X squared minus 2x minus 3. Okay. If I have a problem that looks like this, right? And if I can factor it, I'm always going to, well, I'll put it this way. Anytime the number in front of the x word is a 1, my first step is going to be, hey, can I factor it? The reason being is if I'm going to factor this, my step is multiply the first and the last, -3. What two numbers multiply to -3 but add up to -2? +1 and -3, and then we can just write it as x plus 1 and x minus 3. But could we have used the formula where a was 1, b was -2, and c was -3? We definitely could have done that. The only thing I would tell y'all though, if the number in front of the x word is a 1, try to see if you can factor it, because it usually, if it works, look how quick it is, right? And in the problem that we were doing right now, if you notice, that's what I tried to do, right? I said, look, can I do that? But it just didn't work. So then I said, okay, let's use the quadratic formula. But Laura, you're absolutely correct. We can do the quadratic formula. As long as we end up with an x word, we can do the quadratic formula every single time. And I've had people who say, you know what, it's just easier for me to do it that way because I only got to remember one thing, what's the formula, and it works for them. So definitely you can always do that. Okay, so next part, guys. This part here is called the rational zeros theorem. Okay, and the rational zeros theorem says if P over Q is a rational number in lowest terms, and if P over Q is what we call a zero of F, a polynomial function with integer coefficients, then P is a factor of the constant term and Q is a factor of the leading coefficient. Okay, so it says for each polynomial function, list all possible rational zeros, find all the rational zeros, and factor F into linear factors. Okay, so let me show you how I'm going to go about doing this. So, right here, P and Q. So P is going to be a list, y'all. P is going to be a factor for all the factors of the number -10. So don't even worry about the negative right now. I just want to think of all the numbers that I can divide into 10. Well, we can divide 1 into 10. We can divide 2 into 10. We can divide 5 into 10. And we can divide 10 into 10. Okay? So those would be the numbers that I know I can divide into 10. Whether it's positive or negative doesn't really matter. But not only can we divide +1, +2, +5, +10 into 10, we can also divide all those by, or we can divide -10 by -1, -2, -5, -10. So we really have kind of like double the number that we thought we might have, okay? And then Q are going to be factors of the number that's in front of that leading term. So in this case, the number in front of the leading term is 1. So the only numbers that go into 1 are plus and minus 1. Okay? So those are my numbers for P. Those are my numbers for Q. And then what we need to do, y'all, is we're going to make a new list. We're going to take all the numbers P and we're going to divide them all by the numbers Q. But look at what Q is. Q is just 1. So when you take any of these numbers here and you divide them by 1, you get the same numbers that we had before, obviously still with the plus or minuses, okay? So when it says list all possible rational zeros, this is what we're looking for. We're looking for all the numbers that might possibly work. Now, it doesn't mean they are going to work, but these are numbers that would possibly work, right? That's why it says possible right here, okay? And then, so there's my answer for part A. Now, there's a part B, and it says find all rational zeros. Okay, so this is what we're going to do, y'all. I'm going to take this part right here, and I'm going to use synthetic division. Okay, so I'm going to go like this, and I'm going to write my numbers 1, -2, -13, -10. Okay, so now what I need to do at this step is, remember what numbers I have here. I'm going to kind of write this out separately. So look, one of the numbers is 1, one is -1, one is 2, one is -2, one is 5, one is -5, one is 10, one is -10. Okay, so what I'm really going to do here is I'm going to say, look, I need to find my answers. This is the list that I'm going to choose from. Okay, so what number do I pick? I don't know. This is the part, guys. It's a little cumbersome because it's basically like trial and error. So let's try the number 1. Let's see if that's going to work. Okay, so I'm going to try the number 1. Remember, my first step, bring the 1 down. Multiply. 1 times 1, still 1. Add them together, -1. Multiply again. 1 times -1, -1. Add those together, -14. 1 times -14 is a -14. Add them together, a -24. That's not what I'm trying to get. I'm trying to get 0 as my remainder. Okay, so what does that tell me? That tells me that this number here doesn't work. So I'm going to say, okay, you know what? We were just kidding. We didn't want to try the number 1. Let's try a different number. What number do we try? I don't know. Let's try -1. Maybe that one will work. Okay? So that's why I say, guys, it's a little cumbersome. So look, I'm going to bring down the 1. -1 times 1 is a -1. I'm going to add those together, -3. -1 times -3 is a +3. I'm going to add those together. That's a -10. -1 times -10 is a +10. And look what we got. We got a remainder of 0. Okay, so we're doing great so far. Okay, so far, find all rational zeros. So for part B, I know one of the answers is x equals -1. Okay, remember we said since we had an x to the third and we reduce this, that's my x squared and that's my x term. Okay, so look, now I have an x squared, a -3x, and a -10 equals 0 because I'm trying to find all the zeros, right? And so remember, I told you a little while ago, Lada's question was, can I use a formula? Yes, I can, but because that number is a 1, when I multiply those together, hopefully this works out nice and neat. So 1 times -10 is a -10, and I'm looking for two numbers that multiply to a -10, but if I add them together, y'all, I'm going to get a -3. So what about a +2 and a -5? If I multiply them together, there's my -10, and if I add them up, there's my -3. So when I factor this, this is going to be an x plus 2 and an x minus 5 equals 0. Okay. And so when I set each part equal to 0, and I move that 2 over, that's a -2, And when I move that 5 over, that's a positive 5, right? So we got those numbers there. And remember what we said for part B? We're trying to find all the rational zeros. So we found them. One of them was x equals -1. We did that using synthetic division. The other two we got was x is -2 and x is positive 5. Now, before I continue, y'all, I want to show you something. Remember when I said we were going to pick from this list, and we tried one and one didn't work, and then we tried -1 and it did? Look at the other two numbers that worked. -2 and positive 5, right? So that's why I'm saying that those are what we call the possible rational zeros here, okay? So there's my answer for part B. Now, we have one last part. Part C says factor f of x into what we call linear factors, okay? So I want you to think about something. Remember when we were right here? That's when we factored it out. So look, those are already two factors, x plus 2 and x minus 5, right? And then remember the first answer we came up with was x equals -1. If we were to bring that 1 back, wouldn't that give me an x plus 1? So this here would be my third factor, okay? So I want you to notice something. I want you to look at the signs of my zeros and then look at the factors that we have, right? The signs are the opposite, right? So if there's a -1 here, it's a positive 1. If it's a positive 5 here, it's a -5. If it's a -2 here, it's a positive 2. And that's how we're able to given one of the, or to find all the possible zeros, find the ones that actually work, and then write it as linear factors. So let me ask you all a question. Are we still good? Are we still okay here? Anybody? Don't be shy. Let's see. Yeah, Antonio, you're good? Okay, anybody else? Anybody a little lost? Are we still together here? We're still doing good? Okay.
Yes, doing good. I think my keyboard is just delayed or something.
Oh, okay. No, you're good. You're good. I just want to make sure that we're still doing okay, y'all.
We're
All right. I know.
good so far.
Okay.
It's a lot of steps.
Yeah. So guys, there's no doubt about it. These problems take some time to do. Okay. So I'm gonna look through my. So I have like a ton of videos in my like on my YouTube thing, and I know. And so guys, ever since the pandemic hit, we've been all doing a bunch of online classes. I'm going to look through my list. I'll look through it tomorrow, and I'm going to see if I have any problems, like homework problems from like 3.2 or 3.3. And what I'll do is if I can find a couple of those, I'll send them out to you guys, just so you can see like, okay, and this would have been like, say, either in the summer or last spring or last fall, and somebody asked, how do I do this problem or how do I do that problem? And I'll send those out to you guys so that you at least have something to reference, okay? So let's take a look here. We got a little bit more here left in 3.3. Actually, just two more problems, y'all, and then we'll be done. Okay, so there's something called Descartes' rule of signs. All this is going to do is just help me in terms of when we're doing our problem, how can I figure out, do I have to go through every possible number, right? Okay, so Descartes' rule of signs, and this is just something if you want to use, you can, you don't necessarily have to do it. It says the number of positive zeros of f equals the number of sign variations or the number of variations in sign occurring in the coefficients of f of x. Let me explain what I mean by that. So remember what we're going to do here, y'all. Remember what p is? P is going to be factors of the last number. So I want to think of numbers that I know go into 30. Well, 1, 2, 3, 5, 6, let's see, 15, and oops, I forgot 10. I'm just trying to put them in order. 10, 15, and 30. These are all numbers that I know I can divide into 30, right? I don't think there's any other numbers that go into 30. And think about it this way, y'all. 1 and 30 is 30, 2 and 15, 3 and 10, 6 and 5, right? But remember, not only do I have those, but I have the negative ones as well, right? Okay, and then Q is always factors of the leading coefficient. It's always really, really, really nice, and I try to do this as much as I could, that in your homework problems, the number in front of the leading coefficient, I always try to make it 1 because it just makes it so much easier. So now, remember what I'm going to do. I'm going to make a list of all the fractions. Every number here divided by the numbers that I have there. And in this case, since the number is 1, it's going to be those same numbers. Okay. Okay. So when it tells me to list all possible zeros, this is what I am looking at. Okay. That's what I'm trying to do. That's what it means by list all possible zeros. And now it says find all zeros and factor f of x into what we call linear factors. Okay, so remember what I'm going to do here, y'all. I'm going to pick the numbers that I have: 1, 6, -1, -30. Okay. So remember when I said, y'all, when I was doing this thing here, I really have the numbers 1 and -1, and 2 and -2, and 3 and -3, and 5 and -5, and 6 and -6, and 10 and -10, and 15 and -15, and 30 and -30. Okay, so those are all the possible choices that I could pick from. So remember what I said, when I'm going to do this here, I really have, let me see how many numbers can I pick. 2, 4, 6, 8, 10, 12, 14. I got 16 numbers that I can choose from. And y'all, because this problem here is an x to the third, that tells me that I'm going to have 3 answers. Okay, that's what it's telling me. What Descartes' rule of signs says is, look at the signs that I have right here as I'm going across. Right now we're positive. We stayed positive. We didn't change signs. We went from a +1 to a +6. Oh, look, we went to a -1. That means that we had one sign change, right? Because we went from a +6 to a -1. The signs of our number changed. Now, from a -1, we went to a -30. We didn't change signs anymore. We were negative at -1. We went to -30. We're still negative. So far, we had one sign change. Okay? So what Descartes' rule of signs tells me, y'all, is that if the sign changed one time, okay, then that means I'm going to have one answer that's positive. Okay? Remember, I know I have a total of 3 answers. One of them is going to be positive. Well, if one of them is going to be positive and I have 3 answers, then wouldn't the other 2 need to be negative because I'm going to have 3 answers total? So, and when I say that one answer is going to be positive, at least one answer will be positive. It might be possible that I might have more, but I know that one answer is going to be positive, okay? So what that tells me is I'm at least going to try using those numbers right there. Which one is going to work? I don't know. Okay, that's all Descartes' rule of signs tells me. It at least gives me some idea of what to try. Okay, so look, let's try the number 1 and let's see if that's going to work. So I'm going to bring the 1 down. 1 times 1 is 1. Add them together, that's 7. 1 times 7 is 7. Add them together, that is a 6. 1 times 6 is 6. Add them together. I don't know what I get, but it's not 0, and I want to get 0. So I'm going to say, okay, look, I'm not going to use 1. 1 is not the number for me to use. So let's go like this. Let's scratch out 1. I don't know. Let's try 2. So let me bring down the number that I have here, which is the number 1. And let's multiply. 2 times 1 is 2. Let's add those together, that's 8. 2 times 8 is 16. -1 and 16 is a 15. And 2 times 15 is 30. And look what we got. We got a 0. Okay. So remember we said, I said one of them is positive, but that just means at least one of my numbers is positive. It's possible that I might have more. I don't know. We'll find out in a little bit. But I knew that for sure one of my answers was positive, okay? So I wanted to kind of keep going where we were. So far, we know that we want to find all the zeros. So we know that x equals 2 is one of the zeros, okay? Now, remember we said these are now the numbers in front of my x squared, and that's the number in front of my x. So I'm going to rewrite this as x squared plus 8x plus 15 equals 0 because I need to find the other zeros. I know I'm going to have a total of 3 answers. So remember what we said before. Look, the number right there is a 1. So 1 times 15 is a 15. Okay, I'll make my pen a little bit thicker. Okay, so here we go, 15. I'm looking for 2 numbers that multiply to 15 but add up to 8. What about 3 and 5? You multiply them, you get 15. You add them, you get 8. So look, I'm going to write it like this. And they're both positive, so plus 3 and plus 5. So when I said each of those parts equal to 0, the 2 answers that we're going to come up with are going to be x equals -3 and x equals -5. So I'm going to come back over here and I'm going to say x equals -3 and x equals -5. Remember what we said? We were going to have 1 positive answer and maybe 2 negative answers. Here's my positive answer. Here are my 2 negative answers, right? So again, that's just helping me figure out the numbers that I'm coming up with, right? Now, remember what I said, y'all, these here were the numbers that we were going to try, okay? So we tried 1, it didn't work. We tried -1, it did. And then, we didn't try -1, we tried +2. So we tried 1, it didn't work. We tried +2, it worked. The next numbers that would have worked would have been -3 or -5. I typically, when I'm doing this thing, I mean, there really is no right or wrong way to do it, but I typically try to go, in some kind of order. And because we knew that one of the answers was going to be positive, hey, 1 didn't work, let me try 2. Let me just kind of keep going. Instead of me jumping around all over the place, right? Let me at least go in some kind of order so that I'm keeping track of the numbers that I'm using. Okay, so anyway, here are my 3 answers. Now we're going to write it in the factored form, right? Because it says write f of x into linear factors. So let me show you how I'm going to do this last part. Remember, we're going to have 3 linear factors. Remember what I told y'all before? We're going to look at these signs, and those signs are going to change. So that there should be, if it's x equals 2, it's going to be an x minus 2. And if it's x equals -3, it should be an x plus 3. And if it's x equals -5, it should be x plus 5. Notice these 2 right here, y'all, were from that part right there. And here it is in my linear factors. Okay. Are we still doing okay?
Yes, I was able to
Yeah.
follow that one along.
Okay, excellent. Good, very good. Very good. Yeah, it does take some time to do, y'all. I don't want to lie to you and tell you it's not. I really, guys, when I'm doing these problems here, where did the x minus 2 come from? Let me pull it up again, Lotto, so I can double check. Right here. Remember when we used 2 right here and we got the answer and we got our 0? That was telling me that the answer that I had was, let me get my eraser so I can clean this up. That was telling me that the answer that I had, since 2 worked, that was telling me that x equals 2 was the answer, right? So remember what I said, when you look at these numbers here, to write them into factors, we got to change their signs. So this is a +2, I got to write it as an x minus 2. And if it's -3, I got to write it with an x plus 3. And if it's -5, I got to write it with an x plus 5. Is that better, Laura? Yeah, we're good. Okay, excellent. Good. So guys, one of the things that I really try to do in doing these problems is I try to keep it as straightforward as I could. I didn't try to give you guys like the most complicated ones. I was really trying to give it as simple as I can, okay? So look, we got one more problem here. So let me zoom in and let's see if we can figure this part out. Okay, so it says find a polynomial function f of x of degree 3. So let me tell you what this means here. When it says of degree 3, that means that we're going to have an x to the third. And it says it satisfies the given conditions. Zeros of -3, +1, and +4. And it also tells me that f of 2 is equal to 30. Okay, so let me show you how I'm going to do this. The zeros are x equals -3, x equals +1, and x equals +4. And this is going back to what Lauda asked me a little while ago. Remember what I said, y'all? What I want to do is I want to see if I can write now what the factors would be. So remember, I'm going to move these numbers over. So now I'm going to have an x plus 3, an x minus 1, and an x minus 4. Okay, those would now be my factors. And so when I start to write out my polynomial, I know that we're going to have an x to the third, but I don't know for certain if the number in front of that x to the third is a 1. So what we do is we say, look, we're going to put some number a here. I don't know what that number is. And then I'm going to put this part right here next to it. X plus 3, x minus 1, x minus 4. Okay? And then, since we were given this part to be in the beginning, f of 2 is equal to 30. Remember what this means? That when x is 2, y is the same thing as the number 30. Okay? And remember, f of x and y are the same thing. So I'm going to put a 30 right here. And then everywhere I have the letter x, I'm going to plug in a 2. So I'm going to write it as 2 plus 3, 2 minus 1, 2 minus 4. Okay? So 30 equals a, let's see, 2 plus 3 is 5, 2 minus 1 is 1, 2 minus 4 is a -2. Okay, 5 times 1 times -2 is a -10. Okay. And so now the last thing I'm going to do here, y'all, I'm going to divide both sides by a -10. And we're going to come up with, let's see, -30 divided by, or 30 divided by -10 should be a -3. Okay. And so what I'm going to do now is I'm going to come back to this problem right here. And where we used to have the letter a, we're now going to write it with the number -3 and x minus 4. Okay. Before I go on, what do you guys think? Are we good up to, oops, this? Are we good up to this point, y'all? Did we do okay on this last problem and how we got to where we are? Anybody? Yep, we're good. Easier than the previous. Thank you, Antonio. That's what I was hoping for. Okay, now, I don't want to rain on your parade, but I am going to tell you something. In the homework problem, when you get to your homework, and I'm actually going to pull up the homework problem for you, and because we have time, y'all, once I finish this, I'm going to pull up this exact same problem from your homework. In your homework, it says, do not, this is what it says on the directions. It says, do not factor. Okay, this is what it says on the directions of the homework. Unfortunately, y'all, this thing here is in the factored form. So let me show you how I'm going to do this. I'm going to multiply these together right now. So that would give me a -3x minus 9. I'm going to leave that in parentheses right now, okay? I'm also going to go ahead and multiply these out. So let's go slow. X times x is going to leave me with an x squared. X times -4 is a -4x. Okay, I've used that x. I don't need it anymore. -1 times x is a -1x. And -1 times a -4 is a +4. Okay. So look, we're going to go slow. -3x minus 9. This is now x squared. If I put those two together, that's a -5x plus 4. Okay. Now we're almost done. Let's take this piece and go 1, 2, 3. So -3x times x squared, -3x to the third. Okay. -3x times -5x is a plus 15x squared. And -3x times 4 is a minus 12x. Okay. So look, we've already used this one. We don't need to use it anymore. But we got to do the same thing with this part right here. So -9 times x squared, -9x squared. -9 times -5x is a plus 45x. And finally, -9 times +4 minus 36. Okay, so this is the only x to the third that we have. I'm just going to leave it right there. But we can combine those together. 15x squared minus 9x squared should leave me with a plus 6x squared. And then we can put this one here and this one here together as well. So 45 minus 12 should be something like 33. So plus 33 with an x, and then a minus 36. And okay, now I'm done. Okay, so unfortunately, all in the homework problem, it tells me that. It tells me do not factor. What I'm hoping is that this part here is not necessarily difficult for you to do. It's just a little bit time consuming. Okay, like it takes me time to go through that particular problem and figure it out. But hopefully, you know, we're able to do it, right? It's not like we can't do it. It's just like I'd rather not have to do it, but I can if I need to. Okay, so I'm going to try to pull up the problem that I have. Here we go. Yes, and I'll get to, I saw somebody put something in the chat. I'm going to get to it right now. And let me see. Let me do something real quick here, y'all. Copy this. And let me come back to the chat because I heard something. What happened to the -3x to the third? Ah, you know what? That was my bad. I just rewrote it wrong. That was my mistake. Oops. Sorry about that, y'all. Oops. Let me get my eraser. Here we go. Okay, so let me pull something up for you all so that I can show you. Here we go. And let's go like this. Boom, boom, and boom, boom, boom. Oops, that's not what I wanted to do. Okay, so let me share something with you guys here. And so first thing I'll share is, let's see, let's go like this. And let me stop sharing this real quick. Boom. And let's go the entire screen so you can see what I'm looking at. And that's not what I wanted to see. But look, oops, guys. Oops, I did it again. Oops. Okay. I was just trying to make a joke. So let's come back over here. And so I'm going to pull up the problem that I have directly from the homework. Okay. So let me zoom in so we can see it. Okay. So here's the problem directly from the homework, y'all. I took this problem from 3.3, and this is number 9 out of 3.3. Okay. So it says find a polynomial of degree 3 with real coefficients and zeros of -3, -1, and 4. And notice what it says right here. Do not factor, right? That's why I was doing the problem the way I did it there. So let's see if we can figure this out. here are my zeros, right? So remember, step number one, my zeros are x equals -3, x equals -1, x equals +4, right? Step number two, I'm going to write what we call our factors. So remember, my factors are going to look like this, and taking these numbers and changing their signs. So that should be a +3, a +1, and a -4, okay? And then step number three is going to be, we're going to write it like this: f of x equals a, and we're going to go x +3, x +1, x -4, and we're going to use this little piece of info. So since they told me f of 2 is equal to 24, remember what that means. When x is -2, y is 24, and remember we said f of x and y are the same thing, so I'm going to put a 24 right here, and then everywhere I have an x, I'm going to plug in a -2. So -2 + 3, -2 + 1, -2 - 4, right? And we're going to go through slowly. So we're going to write 24 equals a. Let's see. -2 + 3 is a 1. -2 + 1 is a -1. And -2 - 4 is a -6. And then let's see. 1 times -1 times -6 should be a +6. So now when we divide both sides by 6, we come up with a equals 4, right? Okay, so now if we have a equals 4, remember what we're going to do. Step number 4, we're going to write it like this: f of x equals, I'm going to replace this a with that number 4. X +3, x +1, x -4. Okay. All right, so look, y'all, I'm going to multiply those together. That's going to give me a 4x + 12. Okay. Now I'm going to do these next two, and I'm going to go real slow. So look, x times x, x squared. X times -4, -4x. 1 times x, 1x. 1 times -4, -4. Okay, we can combine those together. So that's an x squared minus 3x minus 4. Okay, we're almost done. We're going to take this one right here. We're going to go 1, 2, 3. So 4x times x squared is a 4x to the third. 4x times a minus 3x is a minus 12x squared. And 4x times a -4 is a negative 16x. Okay, so we've used this one here. 12 times x squared is a positive 12x squared. 12 times a minus 3x is a minus 36 with an x. And 12 times a -4 is a minus 48. Okay. So look, we got our 4x to the third. We've already used that one. Look at this negative 12x squared, y'all, and this positive 12x squared. Those are actually going to cancel out, right? And then I need to combine a minus 16 and a minus 36. So let me get my calculator real quick. Let me turn it on. Negative 16 minus 36. What is that? Negative 52. So that's a negative 52 with an x. And then a minus 48. And so we're left with that part right there. And so let me see. If I pull up my problem here, y'all, just so you can kind of see what I have. So look, 4x to the third minus 52x minus 48. So right here, I'll type it in, 4x to the third. Here's my exponent to the third. Minus, what was it, 52x minus 48. So minus 52x minus 48. There we go. Let me go like this and maybe zoom in so you can see a little bit better. There you go. And then we will check our answer, and we got it, right? So let's see. Let me come back here. Let me come back to my notes. What do you think? Did these problems make a little bit sense in going through like 3-2 and 3-3, finishing that stuff up for y'all? Do y'all feel a little bit better about some of that stuff?
Yes, it does.
Sharing this.
It makes some sense.
Okay, good.
We're super long.
Okay, good. Yeah. Yeah, so it does take some time to do, y'all. It definitely does. I am going to go ahead and stop recording the session, y'all, since we